mga ka-learners, Teacher Angel here. Welcome back to Lesson 2 of our discussion on area. Surface area of a solid. There is a need to know how to compute the surface area of the following solids, so we will know, for instance, the size of a gift wrapper needed for a rectangular box or a cube. If we want to make a cylindrical tin can, we will need to know how many sheets of tin are needed to make a particular size of tin can. Here are the formulas we need to get the surface area of the most common solids we will encounter. Rectangular solid. For a rectangular solid, the surface area is computed as follows. SA equals 2 times the quantity W times H plus H times L plus L times W, where SA is the surface area, H is the height, W is the width, and L is the length. Cylinder. To get the surface area of a cylinder, we use the formula SA equals 2 pi r squared plus 2 pi r h, where pi is 3.14, r is the radius of the top or bottom circle of the cylinder, and h is the height. The first addend, 2 pi r squared, represents the area of the top and the base, while 2 pi r h is the area of the body of the cylinder. Cube. For a cube, we simply take the area of one of the faces and multiply it by 6. That's SA equals 6e squared, where e is the edge. The formula e squared is the same as the area of the square because the face of the cube is a square. Let's try and use the formulas we just learned and apply them to word problems. Example 1. A carpenter was asked to build a box with an area of not more than 7,500 square inches. The box he built has a length of 96 inches, a height of 12 inches, and a width of 24 inches. Is the area of the box not more than 7,500 square inches? For this problem, we can use the formula for the surface area of a rectangular solid, since that is what most boxes are. That's SA equals 2 times the quantity W times H plus H times L plus L times W. Substituting the given values, we get SA equals 2 times the quantity 12 inches times 24 inches plus 12 inches times 96 inches plus 96 inches times 24 inches. That SA equals 2 times the quantity 288 square inches 1,000 plus 1,152 square inches plus 2,304 square inches, or surface area is equal to 2 times 3,744 square inches. Solving for surface area, we get 7,488 square inches, which is 12 square inches below the limit given to the carpenter. Example 2. A sheet of gift wrapper has an area of 864 square inches. How many sheets are needed to wrap a square box with an edge of 20 inches? In this example, we are asked to find the number of sheets needed to wrap a square box or a cube. This means we can use the formula surface area equals 6 times e squared. Plugging the given value for the edge, we get surface area equals 6 times 20 inches squared. Surface area equals 6 times 400 square inches. This gives us a surface area of 2,400 square inches. Now we can find out how many sheets are needed to cover the cube. We can multiply 2,400 square inches by the factor 1 sheet of gift wrapper over 864 square inches. Solving, we get 2.78, which we can round off to 3. This means we need 3 sheets of gift wrapper to wrap the square box we were given. Example 3. A sealed cylindrical water tank in a subdivision is made of concrete. Its outer radius is 3.2 meters and its height is 8 meters. If the tank is painted on the exterior, what is the total surface area to be painted? For this problem, we can use the formula for the surface area of a cylinder. That's surface area equals 2 pi r squared plus 2 pi r h. Substituting the given values, we get surface area equals 2 times 3.14 times 3.2 meters squared plus 2 times 3.14 times 3.2 meters times 8 meters. Computing for the surface area, we get surface area equals 2 times 3.14 times 10.24 square meters plus 2 times 3.14 times 25.6 square meters. That's equal to 2 times 32.15 square meters plus 2 times 80.38 square meters. Surface area is equal to 64.3 square meters plus 160.76 square meters. Adding the final values, we get 225.06 square meters, the area that needs to be painted. Area of an irregular planar figure. Do you have an idea how the area of an irregular planar figure is determined? As we have already discussed, irregular planar figures are made up of planar figures. To solve for the area of an irregular planar figure, divide the figure into regular planar figures like rectangles, squares, rhombi, or triangles. Solve for the area of each planar figure and add up all the areas to get the area of the irregular planar figure. To further understand how to compute the area of an irregular planar figure, study the following example. A farmer wanted to plant kamote in his backyard. He needs to use at least 200 square meters for his garden to gain profit. His backyard is shaped like this figure. Will he gain profit if he uses his backyard as his garden? To solve this problem, we need to divide the irregular planar figure into regular planes. The figure we have can be divided into two. Let's call the first figure the rectangle F1. The second figure can be labeled as F2. Now that we have split the irregular plane into recognizable planes, we can solve for the total area. Let's find the area of F1 first, which we will call A1. That's area 1 equals length times width. Plugging in the length and width of the rectangle, we get A1 equals 20 meters times 8 meters, which gives us 160 square meters. Now let's solve the area for F2, which we will call A2. That's area 2 equals S squared. Plugging in our values from the figure shown, we get area 2 equals 7 meters squared. Solving for area 2, we get 49 square meters. Now we simply add area 1 and area 2 to get the area of the irregular planar figure. This gives us a total of 209 square meters. Sadly, this means it might not be too profitable for the farmer because he can only use 209 square meters. Before we end our lesson, let's look back at what we learned so far. We learned the formulas to solve for the area of planar figures. We also learned the formulas to solve for the surface area of solids. Finally, we learned the formulas to solve for areas of irregular planar figures. Well, That does it for our module on area, mga ka-learners. Congratulations for finishing it. Did you enjoy studying this module? Did you learn from it? I hope you did, because what you learned from this module will surely come in handy. See you in our future modules, mga ka-learners. This has been Teacher Angel for Solar Learning.